Greetings. My name is Mark Cruz. I'm an IT technician from Eagle River, Alaska, and I'm here today to celebrate getting my first Microsoft certification. It's known as the AZ-900 Azure Fundamentals, and it's Microsoft's introductory certification to its cloud computing platform known as Azure. So during my studies at Microsoft Learn, I came across an interesting lab that has you use the Cloud Shell to create a virtual machine and then an extension set command to pull code from a GitHub repository and apply it to the server. So I took this concept and I made it my own with 4 separate labs that take a look at the fundamental concepts a little bit deeper. So all of the code for this is available on my GitHub website under the 25s Azure IaC repository. So the main command we're going to be using is called AZ-VM create. So in the Azure CLI, there's a very powerful command set known as AZ. It's a little different from a traditional command with a dash flag for parameters. It uses these spaces, and then each time there's a space, it's actually a separate command with another set of parameters or another space to make it another command. So we're going to be focused on the AZ-VM command. And then as you can see inside the AZ-VM command, there are a number of other commands like AZ-VM availability set update, AZ-VM capture. We're going to be focused on AZ-VM create. And once you get the first 3 commands entered here, the parameter set can then be applied. It's a very rich parameter set that allows for very detailed configuration. And keep in mind, if you don't apply a value to some of these parameters, then a default value is applied. And a good example is the network security group rule parameter. Depending on if you create a Windows VM or Linux VM, it will create this network security group rule for your RDP or your SSH session. We're going to be using the none option and then configuring our own network security groups with the AZ network command. So the way this will work, I'm going to explain the code, and then we will run the code in the Cloud Shell, and then we will test the infrastructure. So we'll jump into the first lab. So nothing too fancy off the bat. I just defined 3 string variables, a resource group name, the location, and a VM name. I use the AZ group create command to create a resource group, and the AZ VM create command to create a Linux virtual machine with very minimal parameters. For example, I did not specify a VNet, so it will be given a default value of 10.0.0.0/16. After that, we use the AZ-VM extension set command to pull this code from my GitHub repository to then be applied to the Linux server, and it's going to turn it into a Linux Nginx web server. So these first parts of the shell script are installing the dependencies for Nginx, and then we download all the pictures for the website, the HTML web page, and then replace some of the HTML text with server information that can then be displayed from the web browser. And then we will use the AZ network command to create 2 network security group rules, one to open up an SSH port, but another one just to open up port 80 so that we can view the web page in a web browser. Okay, so we'll go ahead and copy the code here. paste it into the Cloud Shell. Okay, so the first thing, we get a nice message here that the resource group has been created. So we'll come in here, and here is the resource group. So there's nothing in it, but as this AZ-VM create command runs, all of the resources that the virtual machine needs will be created. So typically it's going to be the VNet and the network security group rules that we'll see first. Here's the VNet, the VNIC, the public IP address, and the network security group. Next we'll see the disk and the VM, and here they are. And just keep in mind, you have to pay for the public IP address, the disk, and the size of the VM. And so now we get this nice message that the virtual machine has been created, and now it is moving on to the AZ-VM extension set command. So we will get a very nice message here in the Cloud Shell when it finishes, but we can also check on its status in the Azure portal by coming into the virtual machine, going into settings, and extensions and applications. So we gave this extension set the name custom script, so here it is, and its status is transitioning. We'll transition to the succeeded status, and then we'll get a message here in the Cloud Shell, and then at that time we'll know that the shell script has been applied to the server. So these extension sets, they can take anywhere from 3 to 10 minutes to apply depending on the complexity of the script. So I'm just going to pause the video while this applies. Okay, so we just got our message in the Cloud Shell, and if we hit refresh, we'll see that the provisioning has succeeded. Now we're opening up our ports. We're going to open up our port 80 and our SSH port. And we verified that the ports are open, and then we use the curl command just to take a look at the HTML text, and we can see that the server information has been added. So now we can take the public IP address, plug it into a web browser, and then we'll get to our home page. And here you can see the computer name is Ubuntu Web 01. The OS version is 22.04 Ubuntu, and then some specifications about the CPU and then the subnet that it's on, and it also picked up its loopback address. And then you also get this great message about how you just got your Microsoft Certified Azure Fundamentals Victory Mega Man post and all of your happy moose and bunnies. Now we're going to take a look at the second lab. So in the second lab, we're going to create 4 Windows Server 2022 Azure VMs and configure them for PS remoting with a PowerShell command called set AZ-VM extension. So we're going to do something a little bit different in this script. We're going to use a for each loop. So what a for each loop is used for is to iterate through an array of objects. So in this case, our array of objects are the numbers 1 through 7. Each time we run this code, the first time it will be a 1, the second time it will be a 2, the third time it will be a 3. And so I'll just, for folks who aren't super familiar with loops, I'll just paste this in. And then you can see the first loop is running, the second loop is running, and then the third loop is running. So I, in this script, use the for each loop to name the groups and to create the virtual machines. So we already have AZ Fund 01, so I made it X plus 1. So the first resource group that is created will be AZ Fund 02 Server 2022 will be our group. And then we'll get this nice status message that the first loop is running for the resource group. So we also use this X variable to define the virtual machine name. This way, on each iteration, the number will increase. So on the first round, it'll be win-server 2022-01. The next loop will be 02, 03, and then finally 04. So we'll have 4 different computer names, one defined in each iteration. We're using the Windows 2022 Data Center image, and this time we're going to use the AZ, we're going to define the VNet in the AZ VM create command. So by default, it will create a 10.0.0/16 network. So if you create 2 default networks like that, you can't connect them together. So what I've done here is I defined a variable called octet, and it's 15 on the first iteration plus 1. It'll be 16 on the first iteration, 17, 18, and 19. And then I use it to define the VNet address space and the subnet address space. And I replace the second octet with the octet variable. That way on each iteration, the subnet will increase. So we'll get a 172.17, 172.18.19, and .20. Then we'll create some network security group rules for RDP and SSH. And then we'll use the set VM extension set command, but we won't be using it to pull a shell script like we did with the Linux VM. Here, the parameter has you use this command to execute option. We're going to run PowerShell, and then all the commands we need to configure PS remoting. So we're going to do winrm quick config, enable PS remoting. We're going to set a firewall rule, and we're going to define the trusted hosts because these devices are not on the same domain or anything. They're basically like standalone servers on another network, so we have to define some of these trusted host and firewall rules. And then we will test the PS remoting. So in order for this to work, we will have to peer the networks together. So let's go ahead and copy and paste the code into the Cloud Shell. So when I write my scripts, I like to use the write verbose parameter so that it lets you know where you are in the script. So right here, we get this message that loop 1 is running for the resource group. And so when we come here, loop 1 is running for the name of the resource group. So one thing to keep in mind with these scripts, if the Cloud Shell were to fail, like if the web browser was closed or network connectivity dropped, you only get, what gets applied is only as far as you get along in the script. So if you're halfway through your second iteration, that's as far as you get. You still get all those first configurations, but it won't continue after the Cloud Shell crashes. So let's take a look at our resource groups. Sometimes you have to click around to get it to refresh. Okay, and here is AZ Fund02-Server 2022. So here is our resource group. It's got our server, our disk, our network security group, the public IP, the NIC, and the VNet. And then we'll get a nice message here in the Cloud Shell when the virtual machine is officially started. And so we'll take a look at the VNet. Okay, we can see that our virtual machine has started. We are now applying the network security group rules, and we are now using the set AZ VM extension set command. So just like in the Linux VM, you can actually come into the VM itself, go to settings and extension sets. And then see, I named this one PS Remoting. Its status is unavailable, but it will change to transitioning and then succeeded. And then we'll also get a nice message here in the Cloud Shell. So while we're waiting, I was just going to show you the VNet. So this is the address space, the 172.16. And when we take a look at the subnet, it's the 172.16.0.0/24. And again, these extension sets, they can take anywhere from 3 to 10 minutes to apply. So I'm going to pause the recording while the extension set applies. Okay, the extension set has been applied. We get this nice message here. And then also if we hit refresh, we will get the provisioning has succeeded. So now it's moved on to the second iteration. So it ran through all the code, got to the bottom, and now it's going into the second iteration. So it's telling us we're in loop 2, and it's going to start creating the next virtual machine. So let's go back to our resource groups. Here is the third resource group. And now the resources are being created. So in order to have connectivity between these two VNets, we have to connect them. We essentially have two options. We have peering or creating a VPN connection. Since these VNets are in the same tenant, we are going to use peering. So I'm going to go into the first VM's VNet, Win Server 2022-01 VNet, and over here on the left we have an option called peerings. We're going to create a peer. First, we're going to create a remote peer link. And we're going to go to the Win Server 2022-02 VNet. So we want to check these two boxes. We want to allow Win Server 2022-02 VNet to access the 01 VNet and to also receive forwarded traffic from the 01 VNet. And then we also need to create a local peer that allows 01 VNet to access 02 VNet and to also receive the forwarded traffic from the 02 VNet. So these other two options are if you are going to use an Azure service known as a virtual network gateway to create a VPN connection between the VNets. So we don't have the virtual network gateway, so we're not going to do that. And we're just going to stick with the standard peering. Okay, this looks great. We're going to hit add. So the progress on our other VM, it's been created. The ports have been opened, and now its extension set is being applied. So once the extension set has been applied, we'll be ready to test it. So we're going to go ahead and remote in to the first Windows server. So we're going to grab its public IP address. We're going to use the Windows Remote Desktop app. Okay, and we get this nice message here that the extension set has been applied and that it's moving on to the third iteration. So now it's creating the third resource group of Windows Server 2022 servers and creating that third 2022 server. So we're going to continue remoting into our machine here. So we paste the public IP address in there. we have the RDP port open, so we have the connection here. But we have to use the host name and the local username. So the local computer name is win-server 22-01/Windows admin 01. Type in our password. And we'll start our remote desktop session here. So one thing to note about Windows servers is by default, you can't ping them. So right now there is network connectivity with the peer between these two networks. If we try to test it with a ping, it would fail and we might think that there's no connectivity. But in this particular instance, we use the AZ-VM extension set command to configure PS remoting. So even though the ping command is not going to work because the firewall rule is not configured, everything else for PS remoting has been configured and it will work. So the next thing we need is we need to get the local IP address of the other server. So I'll show you guys here. It's going to be this 172.17.0.4. We're going to open PowerShell. Okay, and then what we're going to do, so even though the ping command won't work, the enter PS session command will. So we will type in enter PS session 172.17.0.4, the credential, which is win server, SVR22-02 Windows admin 02. Type in our password. And now we have our PS session. So if I try to ping it though, it fails. So there is network connectivity through the peering, but we can't ping it. So what we're going to do is set the firewall rule to allow us to do this. And there's a few different ways you can do this. You can do it with PowerShell. I'm just using the classic netshell command. So now on the other server, win-svr2202, I configured the firewall for pinging. Try to ping, and the ping is successful. So that demonstrates how to set up the PS remoting between two different VNets using peering. So now while we were doing all of that, our Cloud Shell script was still running. It was iterating through the next loop, and then it went on to now we're on the final loop, the fourth and final loop, and it's creating the fifth server. It's created it, and now it's applying the VM extension set command. So when we come in here, we'll have this really nice naming convention for our groups. So they're all AZ Fund 01, 2, 3, 4, and 5, and then these kind of specify that, hey, these are Windows Server 2022 servers. And then I'll just pause the recording right here, and then we'll wait for the extension set to be applied. And then we'll also come in here to settings, extensions, and then we'll also monitor it here where it has a status of transitioning. Okay, the last extension set has applied and we've completed Lab 2. We're now ready to move on to the third lab. So in the third lab, we're going to create 5 virtual machines from 5 different images, place them all in the same resource group, and then connect them all to the same VNet. So we'll jump in and take a look at the script. So the first thing I do is use this AZ-VM image accept-terms to accept the terms of the Kali Linux image that we're going to be using. So at the time of this recording, that's how I accepted the terms. And then you can use this command to check on the status of your exceptions. Then we create the resource group AZ-Fund06. And then we use the AZ network VNet create command to create a VNet that will be the 172.40.0.0/16 address space. And then I define 5 string objects that are different VM images. And then I combine the string objects into what is known as a collection or an array. And then I use a for each loop to iterate through each object in the array. And then I use a else if block to determine what the VM name will be depending on the image used. So for example, if it finds the Windows 2019 data center, it calls it Win 2019. If it finds the Windows 11 image, then it calls it Win 11-01. At that point, we're ready to create the VMs. We use the AZ-VM create command. And this time we have the image as an object, the network name, and the subnet name defined before we run the command. Then we create the RDP and SSH network security group rules. And then I use 3 if statements to apply additional configuration to the VM depending on what image it's using. If it's using the Ubuntu image, we'll use the same AZ-VM extension set command as in the first lab, and this will pull down a shell script from my GitHub repository and then run it on the Ubuntu server. It will install the dependencies for the Nginx web server, download some pictures, and then replace text on a HTML web page with server information. So then when it finds the Kali Linux VM, it's going to use the same command, but it's going to use a different shell script for the configuration. So Kali Linux is a popular pen testing image. So we're going to install some tools that a pen tester might have. So we need to first download this Kali archive keyring.gpg file and put it in the user share keyrings directory. And then we can install Nmap, Wireshark, Tshark, and then PowerShell version 7. And then I use the echo command in bash to create some PS1 scripts that then we can use to use PowerShell version 7 to run the PowerShell scripts on the Kali Linux virtual machine. And the last if block is if it's the 2019 server, it's going to create a network security group rule for port 80 and the set-azvm extension command to configure the server to be a web server. So right here we're going to install the Windows Feature web server, and then we are going to download the default web page, and then a separate configuration script will be used on the Windows server to get the server information. So here we download some pictures, we create a directory, and then replace text on the home page with server information. And that is the end of the script. It'll just list the open ports for each VM as it's created. So this script does take a while to apply. So I do like to start with a fresh Cloud Shell. So we've got our fresh Cloud Shell, and I'm pasting in the code. And right off the bat, we can see that this command has been depreciated, but at the time of this recording, this is how I accepted the terms for the Kali image. And then we get this nice message that we have accepted the terms. And if we ever want to check on the status, we can use the show command to show us that we have accepted the image. We have created the resource group. So let's check out our resource groups. And now we have the AZ Fund 06-mixed VMs. We have this nice naming convention for all of our resource groups. We're going to go into the mixed VM group, and we're going to see our VNet. And when we check out the address space, we'll see that it's using the 172.40.0.0/16 address space. So it's found the Windows 2019 Data Center server, and it's going to do its configuration. I'm going to pause the video just for time compression. Okay, so the virtual machine was created, and then we applied our network security group rules, and now we get this nice message that it has found the Windows Server VM. And when we go back into the script, we'll see in the third if block the right verbose command that lets us know, hey, this is where we're at in the script. So this particular extension set, it can take like 5 to 10 minutes sometimes for it to apply. So I'm going to go ahead and pause the recording while the extension set applies. Okay, so the extension set has applied. So we're going to go ahead and take a look at what's going on here. So we see port 80 is open, and we've got the public IP address here. So we're going to plug this into the web browser. And then we'll see our status page. So we can see the computer name, Win 2019-01. It's a Windows Server 2019 data center, some information about the CPU, and some information about its networking. And then we also get this awesome message from Megaman congratulating you for getting your Microsoft Certified Azure Fundamentals certification, and then some happy moose and bunnies. So now it's moving on to the Ubuntu web server. And since these are all in the same resource group, what's going to happen is all of the resources for both VMs are now in the same resource group. So they kind of get jumbled up in here, but that's by design. We wanted them all in the same resource group. So the Ubuntu virtual machine has been created, and then we get this nice message that says, hey, we found an Ubuntu VM. So when we go back to our script, we know that we are right here. So it's applying the AZ extension set command. And to check on the status of these extensions, you can click on the virtual machine itself, go down to Settings, Extensions and Applications, and then here we can see the custom script has a status of transitioning, and then we also will get a nice message in the Cloud Shell. This one does apply quicker, but I am going to pause the recording to time compress the video. Okay, so the provisioning has succeeded. So we should get a nice message here in the Cloud Shell. And yes, so we've got the extension finished creating, and we see all of our open ports, and here is the public IP address. So now we'll be able to access the Nginx Ubuntu Linux server. So here we can see the server name is Ubuntu Web 02. It is 24.04.1 Ubuntu. Some information about the processor, and then some networking information. So it's the exact same web page, but one is Linux and one is Windows. So here is the Windows IIS web server and the Linux Nginx server. And this is the Nginx web server from Lab 1, and you can see that it's on a different subnet. Okay, so now it's found the Kali image, and it's creating the Kali VM. So now we're going to see a bunch more resources all jumbled up in here, but again, this is by design. We want all of the resources in the same resource group. So we'll come into the Kali Linux machine. Oh, excuse me. It is, it created the OpenSUSE machine almost instantaneously. So it finished configuring that web server, and then as I was explaining it, it moved to the third iteration and created a Linux SUSE virtual machine. And so with this one, there's nothing fancy about the Linux SUSE machine. I just want to demonstrate how to SSH into these machines. So we're going to open up PowerShell. And it's SSH and admin 03 at the public IP address. The SSH connection has an open port, so we allow our fingerprint to go in, type in the password, and here we are on our Linux SUSE virtual machine. Here you can see it is Linux SUSE version 5.1421. So as I was showing you that, the Kali virtual machine has finished creating, and now it's applying its extension. And again, we can go back to our script, and we can see that we're in the if block for Kali, and it's applying the AZ-VM extension set command. I'm going to pause the recording while the extension finishes applying. And again, you can monitor this from the web portal by going into the virtual machine, going into settings, and then extensions and applications. And we can see that it has a status of transitioning. So I'm going to go ahead and pause the video while this extension applies. Okay, we just got the provisioning succeeded status message. And then we see that we've got our open ports. So I'm going to go ahead and SSH into the Kali Linux machine. So we'll use this public IP address, and it's admin 04. We can see the SSH connection is established. Type in our password. And we can see now we are in the Kali image. So we'll check on Wireshark, which is a GUI-based program. We have Wireshark 4.47. We'll check T-Shark. T-Shark 4.4.7. And then we'll check Nmap. Nmap version 7.95 and PowerShell version 7. So part of the script we're going to change to the user share PowerShell scripts directory. Now I mentioned using the echo commands in bash to create PowerShell scripts. This is where they are stored. There's two of them. the computer name and date, we'll use PowerShell commands to get the computer name and date. And then the Yahoo script, which will import some modules into our PowerShell version 7. So the way you run these is just PowerShell, the name of the script. And we can see that it's using the verbose command to write this information to the screen. So now I'm going to run the Yahoo script. Well, first I'm going to go into PowerShell version 7 and go git module list available. So these are the only modules that we have. But when we run this script, it's going to install some modules for us. And then we get this nice verbose information telling us about the installs. So we'll go back into PowerShell version 7, do the git module list available, and now we have installed these SIM and CyberTool modules onto our Kali Linux virtual machine running PowerShell version 7. So as I mentioned before, you cannot ping Windows servers by default. So we're going to check on our address space. So we're going to go into the VNet, and then our Windows 11 VM has officially just been created. So in our resource group, we now have 5 VMs from 5 different images. Here's the Windows 11 image. So we're going to go into the network and connected devices. And so we already know that the Windows Server NIC, it has this 40.4. So from the Kali Linux machine, I'm going to ping 172.40.0.4. And it fails. So a way that pen testers can find devices on networks is by using a tool called Nmap. And so in this example, the ping failed. So if you were doing a basic ping scan, it wouldn't pick up the server. But we're going to run a ping scan, or excuse me, a port scan on the entire network. Just make sure you spell Nmap right. So this does take just a second to run. And so basically this is saying do a port scan on 172.40.0. every address in the network. And so even though we couldn't ping the Windows server, we found the device. Here's its IP address, and we can see that port 80 is open, port RDP port is open, and this TCP port is also open. And that's and the other important one is this WSMan. So that's the Windows Remote Management Service. So that could be a clue to a pen tester that, hey, this is probably a Windows device. Okay, so that is our Kali Linux machine. And that finishes Lab 3. Lab 4 deals with a technology known as containers. So the Microsoft Learn curriculum focuses on the platform Docker to host its containers. So here on the Microsoft website, there are 4 different kinds of container images that you can pull into Docker. And so this lab is going to focus on standing up a virtual machine, installing the Docker runtime, and then creating containers to run our web page, our web server. So in this particular instance, I have 3 virtual machines that are just running a basic HTML web page. In this case, I don't necessarily need a full-blown VM to host that one web page. So what containers can allow us to do is create multiple instances of a runtime to then run applications in a containerized format. So I'm going to go ahead and jump into the script here. There's nothing too fancy here. We're just creating a group, and then we're creating the VM. One thing to note is I am using a specific size VM here. I am using a standard underscore DS2 version 3. It supports nested virtualization. So most container runtimes are focused on Linux, but when you're talking about Windows containers, we can actually use Hyper-V. So we are going to be installing Windows containers using a Hyper-V server. So we're going to use the set-azvm extension command to install the Hyper-V role, and then we also need to enable the containers feature. And then just reboot the server here. So let's go ahead and create our Docker host. And then just really quickly, these are other SKUs that you can use for VMs that support nested virtualization. For example, if you're using Hyper-V, you have to enable nested virtualization with a command known as set VM processor, and you expose some of the CPU to the virtual machine. Okay, so let's go ahead and run this in the Cloud Shell. So it's created our resource group, and now it's going to create our Windows 2022 data center on a 10.70.70.0/16 network. And here is the Docker host group. Okay, now all the resources have been created, and we'll wait for the virtual machine to finish its configuration, and then it will move on to applying the VM extension. I am going to pause the video here while the VM finishes creating. Okay, so the virtual machine has been created and it's running, and now it is applying the extension. So it's going to install the Hyper-V role, enable the containers feature, and then restart the VM. So this particular extension set does take some time to apply, so I'm going to pause the video while the extension applies. And while you're waiting for these extensions to be applied, you can go into the virtual machine, and under settings, under extensions and applications, you can monitor the status here. You can actually create it all. You can do it all in the web browser. If you don't want to use the Cloud Shell, you can click Add and then find the custom script extension and then configure it that way. But here we're using the Cloud Shell. Okay, we just got a nice message here in the Cloud Shell that the provisioning has succeeded. We can also see that in the web portal. So now we're just going to RDP into this guy. So the name is Docker host, admin 01, password. So the first thing we have to do is download and install Docker. So we're just going to go to the Docker homepage and download the runtime and install it. Okay, now that we're on the host, I'm going to open up PowerShell. Just to show you that we are on the Docker host. And Docker is not installed. So we're going to open up a web browser. So we are on the Docker Docs website. We're going to download Docker Desktop for Windows. Okay, so we're going to install Docker. So depending on what kind of containers you're running, you'll do different configurations here. So the default, it wants you to use the Windows subsystem for Linux instead of Hyper-V. But we have a Windows server with the Hyper-V role installed. So we're going to uncheck that box. And in this case, we want to allow Windows containers to be used with the installation. There is some concern about security. It has to do with the administrator account, the container administrator account. But for this lab, this are the settings that we are going to use. Okay, excellent. Now Docker will install. I'm going to pause the video and come back after the install completes. Okay, excellent. Docker has finished installing. We'll click close log out. It will terminate our RDP session, so we'll go right back into it. So there's a few default settings that we want to change in Docker. So we're going to go ahead and start it up. And there we can see the Docker runtime in the background. And then we get, I love these cartoon characters, especially the whale. Docker's mascot is a whale. So we're going to click accept. Okay, we can see the engine is starting. So we're going to go right into the settings. And right here where it says choose container terminal, we're going to select system default. And then under the Docker engine, under experimental, we're going to change this to true. Click apply. It was unhappy about the capital T. Okay, once that applies, there are some updates. So we're going to apply the updates. Okay, and now we are up to date. So I'm going to close the settings. So the first thing we need to do is pull an image. So there are all kinds of images on the Docker Hub repository, but Microsoft has their own images for Windows Server Core, Nano Server, and Windows Server. And so what we're going to do is use the Windows Server 2022 core image to create our containers. So this is the command to pull that container, and actually that's for 2025. And there's one more setting that we have to set here. So we're going to open up PowerShell. And we're going to run the Docker CLI exe, which is located in Program Files, Docker CLI .exe, and then the parameter is switch daemon. And so after we switch the daemon, we're officially ready to pull our first image and start working with containers. So I'm going to just restart PowerShell. And we're going to pull in the 2022 server image. So you can see docker-v, Docker version 28. And now we're going to pull in the 2022 server core image. So it downloads pretty fast. You'll actually see here within a few minutes it downloads. But then as part of the pull process, there's some extraction that happens. So this does take a little bit of time. I am going to pause the recording while we are pulling in our server core 2022 image. Okay, so we've officially pulled in the image. And in the GUI, we can see here from the Microsoft Container Registry, we've got our first image. So the command to create a container is docker run. We're going to call this its name is going to be IIS set. And then you have to specify this IT parameter or your containers will not stay started. And then we put in the image and then type PowerShell. So this will create the container and start an interactive PowerShell session with the container. Okay, and we can see that the container has been created. It's running. And now we're in the session. You can see it's got a host name and its own IP address. So what we're going to take a look at, we're going to get Windows feature for the web server role. And so the web server role is obviously, it's not installed. So what we're going to do is install the feature, and then after the feature is installed, or excuse me, the role is installed, we're going to commit that to an image and then create other containers off of that committed image. So we can actually just take this and pipe it to install Windows feature. And then I like the verbose parameter to give us more information about what is happening. And this part does take a moment. I'm not sure if it's related to container resources or the core image, but I am going to pause this just to time compress the video just a teeny bit. Okay, so the role is now installed, and that took about 5 minutes, which doesn't seem like a lot of time, but we're going to make 10 of these containers. So if that takes 5 or 6 minutes, you're looking at an hour of just watching the progress bar, where now we have the web server role installed on this container, and we're actually going to commit it as an image and then create other containers off of this committed image. So we run docker ps-a to see our containers. We've only got the one. And so the command that we are going to use is docker commit. We'll plug in the container ID. And then we give it a tag. So we'll bounce back over to the GUI, take a look at our images. So right now we've only got the Microsoft Container Registry Windows Server 2020, or Windows Core Server 2022. Just a moment, we're going to see our committed image added to the list. Okay, and there it is under this Yahoo testing image. So now we're going to create a container based off of that image. So I first run the Docker images to get the ID. which is this 4.1. So this is the exact same command we used to create our first container, but we're just using a different image, and we're going to call this IIS server 1. Okay, our container is up and running, and now what we're going to do is we're going to configure it to be a web server just like all in the previous labs. So I'm just going to paste it directly into the container PowerShell session. It's going to create this directory. It's going to download the HTML web page and the configuration script, and then run the configuration script to put the server information onto the web page. Okay, so we'll get the IP address of the container. And so now here's our container. So the computer name is the container, but it thinks it's a Windows 20 Server 2022 data center, and that this is its processor and this is its networking information. So that's pretty neat, right? That we were able to do that. And so now the power in this is, let's say we want to make 10 of these. So we can just go into our Docker shell. So when you click exit, it's actually going to stop the container. And then since we use that IT parameter, we can just start it right back up. If you don't use that -IT, the container will just start and then stop. So when you use that IT container, it allows it to keep running. So we'll just use the up arrow. So this is the exact same command that we want to use. We just want to change the name of the container. And so now I'm going to show you a different way to configure this. So we're going to hit exit, and the container is going to stop. So we'll just start it back up. There is a command known as docker exec, where you can use it to run PowerShell commands inside of the container. So here is the command. So instead of copying and pasting this directly into the container session, we are going to execute it from the host. So we'll paste in this command. We need the container ID. We can tell the name here on the side. So we want the server 2. So this is its container ID. Plug it in here. And so this is going to run these PowerShell commands inside of the container. So you can see it's created this temp directory. For the Yahoo script, it's created the JPEG directory. Now it's going to be downloading the images, the default web page, and then running the configuration script to replace that HTML text with the container server information. Okay, so we need to get the IP address, so we can just use the exact same structure, but instead of this big long string, we're just going to do IP config. Get its IP address. So that's pretty cool. Now we have our second container that is running our custom web page with the server information. So now what we're going to do for speed, so we're going to do this 10 times, and we're just going to enter it directly into the terminal each time. So we'll go back to our Docker run, change it to 3. Paste our configuration. So when the container is stopped and started, it will get a new IP address. So if you use the IP config to get the IP address in an interactive session, check out the web browser and then close your container and then start the container, it's going to have a different IP address. So what we're going to do is hit exit each time and then start the container. And then we will get the container ID. And then we will get its IP address with this command. We'll test it, and then there's actually a faster way to do this where we can get all of the IP addresses at the end. So that's our third container, right? So we had 3 full-on VM web servers in the previous labs. So now we have one host that is hosting 3 different IIS web server roles. Okay, so we're going to go in and create number 4. Paste the configuration. Actually, I think we can just use the up arrow. Oh, no. And so actually, to even speed this up, you can start opening other shells, right? So that was 4. So we'll go ahead and create 5. And 6. I'm just using the same configuration. And there's different ways you could do this configuration, but for demo purposes, this is kind of the fastest way that I've found. Okay, and we'll take a look at what we've got going on here. So we've got the 5. Let everything just kind of catch up here. Okay, so we'll do 6. Excuse me, 7. And 8. Okay, so we've got our containers here popping in. So we're going to do 10, so we're going to do 2 more. Okay, I might get a little crazy with it here. So I've got 4 PowerShell sessions going. And this last one, 10. So he's finished. Okay, everything is looking good. So we're just going to create these last 2 containers and then test the web pages. And you can see each time I exit, the container will stop. And we'll just start it right back up. Excellent, so we officially have all of our containers. So the ways I showed you how to get the IP address, they're kind of slow. So I discovered a way to get all of the IP addresses. So first you do the docker network ls command to get the network ID. And then we're focused on this NAT network here. So we use that ID. And then it's going to present us a JSON object where we can pick out the IP addresses. So I am going to just start over, do each one. And actually, to keep track of everything, I'm just going to copy this into Notepad just to help me keep track of everything. Okay, container 1. Here is container 2. Container 3. I mean, this is pretty wild. And then container 4. Container 5. And you can see they are all working. This is 6. 7. 8. At 9. I think I missed one. I might only have 9. Let me count real quick. Oh, one is not running. what we'll do, we'll just go docker ps-a, and then docker so its image is this, starts D727, ends in 02A. Oh, I'm sorry, I did not delete the first image. Sorry about that. I had a little problem there, but here is the IP address of our 10th web server. We can see we've got our 10 IIS containers running our 10 web servers. Okay, and so when we look at each one of these, it'll have its image container ID as its computer name. So, but each one of these has all of the same information. So now we have 10 messages from Megaman congratulating us on our Microsoft Certified Azure Fundamentals certification, and we get to celebrate with our happy moose and all of our bunnies. So if you're able to get through all 4 labs, congratulations. It took me a little bit of figuring to get all that to work. But now that we have the infrastructure set up, I want to do another demonstration of the VNet peering. So I'm going to go in here to our resource groups, and you can see we've got our very well labeled resource groups. And what in the AZ Fundo 1 is a Linux web Nginx server. And then in the mixed VM group is also an Ubuntu Nginx Linux web server and the Windows 2019 IIS web server. And so we're going to peer that with this AZ Fundo 2 network and then access the web pages by their local IP addresses instead of their public IP addresses. So we're going to go into the AZ Fundo 2 server group, find the VNet, and we actually already have one peering set up from Lab 2, and it goes to the other Windows server so that we could test the PS remoting. So we're going to add another peer. We're going to call this the mixed remote. And then we'll find the mixed VM subnet. And then we want to check these 2 boxes to allow the mixed VNet to access the server VNet and to also receive forwarded traffic from the server VNet. And then there's also a remote peer where the server VNet will access the mixed VMnet, and it needs to be able to receive the forwarded traffic from the mixed VM VNet. So these other 2 options, they are if you plan on using a virtual network gateway to create a VPN connection between the VNets. So a good example for that is if you had a VNet in 2 separate tenants, you could use a virtual network gateway and then make the VPN connection between the VNets. Since these VNets are in the same tenant, we can just check these 2 boxes and do the basic peering. So I'm going to click Add, and the peerings, they generate pretty quickly. Excellent. And so now we're going to do the same thing, but to the Ubuntu. So we'll find the Fund01, Ubuntu Web 01. Check the 2 boxes, make the local peer. And now we have all of our peers set up. So peers are not transitive, so if you peer to one network and that's peered to another network, you can't access the third network from the first network. You have to have the direct peering from VNet to VNet. So we are going to go into the AZ Fund group into our Win-Server 2022-01. Grab its public IP address. We're going to remote into him. Okay, so this server is on the 172.16 network. Its IP address is 172.16.0.4. But now that we've set up the VNet peering, we can access the Linux server by its private IP address rather than its public IP address. And then it's the same for the Windows server, so it's on the 172.40.0.4. And so here is the Windows 2019 Data Center server, and then I think 0.5 is the other. I thought it was the other Linux server. Check that. So we'll go into the mixed group and network, connected devices. We want this one. Yes, .5, 40.5. Okay, it just took a second for it to load. So here, that's the wrong. Oh, excuse me, this is 172. Sorry about that. Okay, and then now this is Ubuntu Web 02. So the last. So when I was creating this lab, I came across a number of challenges. One of the more interesting challenges had to do with quotas. So you can see what your current quota situation is by entering this command. Let me just clear this out of the command prompt. And so this will list all of the different quotas that you have. And so the standard BS2 family vCPUs, you get 10 and you see I've used 8 of them. And so I discovered, oh boy, I've got to use different families to not hit these quota limits. But then what happens is you have a region limit that the default is 10. So I was hitting this, it wouldn't let me create any more virtual machines because I had hit my quota. So the documentation is, it's pretty good about how this works, but basically you can request more in your quota. And so you do this through the Azure portal by going to quotas. And then we're concerned right now in this example with compute. And so this will be a graphical representation of the information we're looking at down here. And so the one that was giving me trouble was this total regional vCPUs. And you see I've only got 2 more that I can use. So it's a little tricky. You actually don't want to click on it. You want to check this box. And then new request and enter a new limit. And I thought this went to like Microsoft bureaucrat somewhere, and I like had to wait. But it's automated, so it does take a second. So I'll go ahead and submit the quota. It tells us it's reviewing it. And when I've only done this one time. I increased it from 10 to 20, and within a matter of minutes, I had the quota increased. So we'll just kind of wait here until we get the confirmation message. So I'm going to pause the recording while we wait for the quota to be accepted. Okay, excellent. We get this message that our quota has been adjusted. So we'll go in here and run the command. And we can see that our regional total regional vCPUs is now increased to 25. So that was one tricky part. Like I said, the other tricky part was finding the images. So I did find this neat, it's like a web page based tool that you can use to find the information that you need. And basically it's this urn. If you plug this urn into the image parameter, then it will work. Right there was just kind of a filtered list. You can click on show all. It does take it a little bit to load, and then you can see all the different images. But we can also search for images in the Cloud Shell. So you kind of have to learn the syntax of these, but basically it's AZ VM image list, and it's all about this query parameter. And so basically you put these square brackets and then a period, and then you search, this is what you want to call it, and then this is what it is, and then it will output it into a table format. So this is every image. It is pretty sweet. It lists like so many that I think the cloud, or that the command line runs out of space for them. So if you specify if you just do AZ image list and then this query, it'll be a much quicker search. So we'll go ahead and just apply this. And so here it lists the alias of the urn. This is what you want for the image, its SKU, and then who offers it. And then the other way that I figured out you can search, so that's listing everything and just formatting it. So this query and then the brackets, that's basically just sorting it, or excuse me, just putting it into a table. But we can use the sort by to sort the results. And this time we're just going to list the publishers instead of the actual images. And so then it will start to list all of the publishers. And you can see they've got some odd names. Like we just scratched the surface in these 4 labs. And then the last one is this contains. So it's question mark contains. So I want to search for through all of the image, but I just want to see the ones that are related to Kali, that contain the name Kali, and there's only one. So those were just some helpful commands that you can use when you're going through the labs. So I want to take a moment and say thank you for watching. And at the very end here, we're just going to clean up everything that we did. So on my main celebrate script at the very end, I have how to remove everything. So what I'm going to do for those Windows Server 2022 groups is I'm going to use a for each loop to delete these resource groups. And you have to do -- yes to have an uninterrupted deletion. And then, so we're going to paste this into the Cloud Shell. And so now this will just sit here and run and delete those resource groups. And then we're also going to come in and delete them just with the Azure portal. So when you delete a resource group, all of the resources inside of the resource group get deleted. So now in about 5 minutes, all of this will be deleted, including the resource group. So in our mixed VMs example, when you're doing testing, you can see how valuable it is to put all of your test objects into a container and then, into a resource group. And then when you're done, you can just nuke the resource group and then go back to square one. And then we'll delete the Docker host group. And so the iteration deleting is just kind of a neat, fun thing that you can do. It's actually not going to be any faster. It's actually, see, it's still deleting the first group. So it hasn't even got to the other one when I can just pop in here and just start deleting them from the opposite side. So I'm just going to come here and delete these. And I'll probably be done by the time it moves on to the, to the third one. So you could just go in and delete each resource one at a time, but you could see how tedious that would be. So this is nice that you can just click on delete the resource group and it will delete. Okay, we can see our first resource group was officially deleted. And you could actually go in here and monitor everything. Oh, that's actually been deleted. Thank you for watching.